All right, so let's take a look at DNS. So if you open this one, this is a page I learned how to do this in HTML5 that made me happy. It keeps connecting to all these random servers at my domain. And so if we look at that in Wireshark, we can see what's happening. If I load up Wireshark, and I just start sniffing on the adapter that has traffic, double click, okay, then I mostly see the traffic for this stream, but if I want to see just the DNS requests, I put DNS. Okay, and now I'll see, here's all these queries going by. Server 111, server 638, and so on. I can see it making all these requests. I'll stop. So I can look at it. So here it makes a request for server 160, and then it gets an answer somewhere. 7D67. Here's some response. At some point I'll get a response, and I could follow it. In fact, they're right there it is. Here's the request, here's the response. Okay. And the response is, I think, not going to find it. I can find out if I right-click on one of these and follow the UDP stream. It'll show me they gave a response, but it's unreadable binary. Anyway, I don't really care about the response, although it is down here. The response is going to be server not found, I think. Query, yeah, no answer. So it didn't find it. Answer's 0, which is fine, but it did DNS requests. Now, the point of this is, if you get infected with malware and you're a bot, then your machine will send fake traffic to announce the presence of the bot to the bot master. And it usually hides that traffic as HTTP, HTTPS, or DNS to be a common protocol. So one thing that is commonly done is it encrypts the data and puts it in a domain name, which goes to the command and control server, and it extracts data from these requests. And that is passed by your firewall and your IDS and everything because it looks like normal query traffic created by surfing the web. So we can make a DNS monitor to watch the DNS traffic on the network the way we did with Wireshark in Python. So to do that, you need to have Scapy, which I think I already have, but this is how you install it if you don't have it. There, it downloads and installs it. Okay. Well, see, I think I might have to use Linux for this because, as I remember, there's trouble doing this in the raw Mac, but we're going to see if it works. So I'll do DNS1. Okay, so there it is. Let's see if this works. And by the way, first I'm going to run it, then I'm going to come back. So let's do Python 3 DNS1. Oh, good. Yep, it's working. All right, good. Now let's talk about it. All right. So this imports from that library Scapy, which is a packet capturing library that lets your Python do essentially the same thing Wireshark does. And I see, I didn't pull this correctly. All right, improving my amateur theater setup here. So now, here's the active ingredient. The def defines a subroutine, which does not run until you call it. This is the only command that's actually in what you might call the main routine. It's going to sniff the network, which is a Scapy command, and then it's going to, when it finds anything, it's going to send it to find DNS, which is this subroutine. And now it's going to call it with the packet that it just received. So if the packet is a DNS packet, it'll have this layer, and then it's just going to print a summary of the packet and the whole packet. So all this does is listen for all the traffic going by and ignore everything but DNS, and for every DNS request, it prints quite a lot of information. And that's what you see here. So here's a DNS request, UDP, domain is 53. Here's the DNS showing a question looking for server 431. And this looks like an answer. Answer is none. So that's a DNS reply, and someplace up here will be the DNS request. So anyway, in principle, it's bringing out the DNS information, but it's presenting it in a pretty unfriendly, nasty form that's too hard to look through. So you want to make a cleaner monitor, and that's DNS2. All right, this is just the same as before. The only thing is, instead of printing everything, just print the IP source and a summary of the DNS record. So I'm getting a smaller amount of output. So let's see how that looks. DNS2. All right. And so there we are. Now I only get 1 or 2 lines of data for each one. And so I can see what's going on more easily. Here's the various server names going by at samsclass.info. All right. And so now there's a page here that prints long random strings, and one of them just has the flag in it. So if you just run the monitor for a while, you'll find the flag buried in among the other traffic. Then there's one where here there's a whole series of these with more and more difficulty in them. These are getting you closer and closer to real botnet traffic. Some of them keep changing the random things a lot, but there's one that doesn't change. Some of them encode the data that's hidden in there with base 64 or base 32, which is what you really use for DNS. You use base 32 instead of base 64 because DNS doesn't know about case. If I go to yahoo.com and then I go to capital yahoo.com, I get to the same place because DNS is not case sensitive, so you cannot encode data for DNS with base 64, where a capital A and a lowercase a mean different things. You have to encode it with base 32, which only uses, I think, the capital letters, not the small ones. So that's what you really have to do. And that's the game here. There's one with hex encoding. Here's binary encoding, base 32 encoding. There's a variety of challenges here where you try and find out what's in this traffic, the obscured data that's leaving. All right.